Today I'm going to teach you the most efficient way to produce hydrogen oxygen flame at home. So guys, we are going to need a tape. Okay, after completing the taping process comes the second part, which is electrical isolation. Okay, so this is the part, this is one of the parts to be specific. Done. Now comes the isolation, electrical isolation of this. So the electrical isolation has completed. Now comes the head part. Okay, now I have taken a tighter belt to further prevent the air from escaping from the sides. Okay, now guys, on this pressure cooker cover I have also placed a black insulation tape. Okay, now why I have done that, you will understand it later in the video. And here, as you can see, the rubber belt that is also placed here, and this part is done. Now comes our 12 volts UPS battery. This needs to be recovered and needs a lot of charging. I haven't used it, I haven't charged it for almost 8 or 9 months. Okay, so guys, it's time to open all the knobs to see about the water level and then start the recharging process. Well guys, here I'm using rainwater. Okay, and there are a few slots in which there is very less water. Okay, 1 second. Yeah, you see no water in this one, but water is present in this one, and again no water in this one and this one. So I will have to fill that out. Now guys, here what you see is a triangular metallic piece. Okay, so I need it for the conduction of electricity, and this pin for connecting to one of the terminals of the UPS battery. Okay, so I am going to choose the negative terminal of the battery. Okay, this one is the negative terminal, so I've connected to the negative, and it is going to come below the battery, like battery is going to reside on it. So guys, after doing the connections, you are going to need one more pin for the positive terminal, but we will connect that later. So let's remove the wooden board, not needed anymore. And now we need is the pressure cooker itself. This is also not needed. So it's simple enough. Place the metal sheet, you see this metal piece below it, and keep the battery. Yeah, battery is in place. And guys, I've placed this metal sheet this way because I need the negative of the battery, you see, to get in contact electrically with this part of the cooker. Okay, and this side is still open. Okay, let's do the connection for this one. So guys, this is the cooker cap, and now what you have to do is use some sieving machine oil, and place it on the belt. This further prevents the air from leaking. Okay, yeah, done. So with that being done comes the part of placing this wire. Sorry, the oil is getting leaked. So guys, I will quickly show you because the oil starts leaking up. I have placed the wire over here, and now what I have to do is connect this terminal to the positive terminal of the battery. Okay, and this is a little tricky because the negative has been connected to this part and positive has been connected to this part, and for that reason I placed this insulation tape over here and here to prevent any short circuit. I am electrically isolating this pressure cooker piece and this piece. Okay, so that's why I've also placed tape over here and here, just a precaution, and after that connect it like this. Yeah, this has connected successfully. Now what we can see is this part of the pressure cooker is the negative. Okay, and this part, the head part, is the positive. Okay, now a little bit careful. Okay, so this is completely locked. Now guys, to make sure that there is no short circuit condition, what I'm going to do is measure the voltage. So I've pointed it to 12 volts DC mode, and now I'm going to touch these pins to the cooker to see the battery voltage. Here, as you can see, that it is showing the full voltage, indicating that there is no short circuit occurrence. So guys, to the nozzle, as you can see, I have connected a pipe, and this is the end exit point, and the point is to collect the gas in this balloon. So taking the balloon and placing it like this, and using a plastic rope, well, you can use whatever you want, at least that is what I am doing, to tighten up the balloon. Okay, it is very important because the pressure might just blow it away. Yeah, done. Now it's time to charge the battery. Remember that this side is positive and this is negative, as I told you before, the connection part. And guys, 15 volts 3 amperes charger is what I'm going to use here. You can see output 15V 3A and input of 100 to 240 volts. Okay, laptop charger, and these are the two terminals. White one is positive and black one is negative. Little rusty because I've been using it on like a sulfuric acid, so it has corroded, but still works. Now guys, there is a place over here, a little grove. I'm going to connect the negative to that point. You see, connected successfully. Now the positive is left. The top head is positive, so I'm going to connect the positive to the top head. Okay, done. At present the connection seems fine, everything seems fine. You can see that there is a little inflation of hydrogen gas. Even when it is not charging, it still produces hydrogen oxygen gas. But yes, the truth is that we need a lot more than that. Okay, so here I'm going to turn on the switch and you should see some change. You can see that the balloon is inflating little by little and a bit more than before. Very soon it is going to enter the recovery mode. Current is a little more than before, it is 0.23. A lot more current is needed for fast filling of balloon with air. Although you can see that it is inflating but taking a lot of time. Well guys, after a time period of about half an hour or 45 minutes, this balloon inflated like this. As you can see, here I have also made this nozzle for the flame. So let's carefully take it out from there and place it over here and then see how good the flame is. Well guys, the bad news is that the balloon burst out while placing this at the balloon's opening. So I think I will have to do this again with another balloon. Well guys, it took around 20 more minutes and you can see that it is inflated this much. I think I should continue with the experiment before I fill it up completely and then it blasts. Yeah, now it seems fine. Whoa, you see? Pretty good flame. You see, good flame. Whoa, what is this? You see? It is like it is traveling.
Hi, these what you see are my 10 years old 12 volts 7 ampere hour UPS batteries, and in this video I'm going to use them to make a very powerful 24 volts UPS power supply.
Next level. Next level.
Now, before proceeding any further, check out this product. It's a smart multifunctional charger with soft start function, USB output to charge mobile phones, and it automatically identifies the battery type. And here is the list of compatible batteries. User manual, and the device itself. So here I have some lithium-ion batteries at 3.7 volts. Let's connect them to our new charger. It's flashing that it is at 50% and it is charging. The charging current is 500 milliamps. Oh, this one says 2 amperes for USB output. Let's connect it to this point. Whoa, you have to hold it for some longer duration, and now it is providing 700 milliamps again, and here we have 1000 milliamperes once again, and that is 2000 milliamperes. Yeah, now it is 500 again. Let's connect all the batteries. Let's try the power bank mode. And now it is charging. 80%. So it's a pretty good device. Link to buy it has been provided in the description. Now let's do the voltage check. 12 volts, 10.6, 10.3, 11.72.
Next level.
So after charging it for some time, the new voltage for the batteries are 12.10, 11.8, 11.44, 11.74. So for some reason I have to keep these batteries from going beyond 12 volts because the output has to be fixed at 24 volts. Moving on to the next checking part. It's fine. Now, this what you see is a very strong steel base from an old PC. So guys, here I have finally completed my 24 volts 14 ampere hour battery pack. Now I have these two power supplies. One is 18.7 amperes and the other one is 20 amperes, and both are 24 volts. Here the label, as you can see, 24 volts 18.7 ampere, 24 volts 20 amperes. So let's use this one. So let's turn on the power supply. These three pins are positive and these three are negative. As you can see, 24 volts.
Negative, positive.
Now this point, the tapping point that you see, is the overall positive of this entire battery pack. So this yellow wire needs to be connected over here. So the positive terminal has been connected successfully. Now comes the negative terminal. This one has to remain open because this overall negative from the power supply will be connected to the overall negative of this battery pack. So finally guys, the device is fully complete and now it is time to test it, which involves this very important device. Here you see two plugs and one output. In the middle is the contactor. Now this plug is 110 or 220 volts home socket supply. The next one is your 220 volts or 110 volts inverter plug, and load will be connected to the final output. Let's first connect the home socket mains plug. Now when I turn on the mains board, the contacts are made on the contactor and the bulb lights up. And when I turn off the board, the contactor is released and the bulb turns off. Now let's say that I have an inverter connected to my inverter plug. So turning on the mains and plugging in the other battery terminal. Now let's cut off the mains. You can see that as soon as the power turned off, the inverter kicked in and the bulb kept on glowing, although there was a small delay, huge enough to turn off a working printer, thereby wasting your print material and electricity. So this is where my 24 volts UPS fits in. Now instead of this small inverter, I am actually using this 1.5 kilowatts inverter and this giant 150 ampere hour 12 volts battery. So instead of connecting my 3D printer directly to the contactor output, I decided to build this 24 volts UPS to solve the delay problem by simply connecting the output of my contactor to my 24 volts UPS and then connecting the output of my UPS to the 3D printer, because a 3D printer mostly runs on a 24 volts SMPS supply. So I opened the bed box of my FL Sun V400 and took out the power supply. Plus, I also took out these two red and black wires that were connecting to the power supply. After that, it is obvious that these two red and black wires will be connected to the output from my 24 volts UPS, and that's it. Hi guys, this what you see is a 12 volts 7Ah computer UPS battery, okay? Looks good, but it is 5 years old. Now let's measure the voltage to find out how much charge it has so that we can proceed further accordingly. As you can see that the voltage it is showing is 12.13 volts, which means that according to this display it is fully charged. Now guys, this is a 12 volts 55 watts bulb. So when I will connect this bulb to the battery, you should see the voltage, okay? You see that the voltage reduced to as low as 7 volts. Again, yeah, around 8 volts, 7.85 or 8 volts. So this shows that the charge on the battery is not only indicated by the voltage on its terminals, but also when we connect a load to its terminals, and it does not drops that easily.
Now let's open these slots to check the water level of the battery. Here as you can see guys that the water level looks good. You see here and here, here and here. Finally, I think water is missing in this one, so we have to fill water in this. Now guys, for filling of the water I use rainwater, which I would recommend to you too. Steady, steady, steady. Yeah. Okay, and after that simply place it in and slowly fill it. Yeah.
And guys, now comes the part of boosting the battery voltage, okay? So to fully boost and recharge the battery, I'm going to use this laptop charger, 15 volts 3 amperes. And remember guys, you will have to use a charger from 14 to 15 volts because the battery is already showing a voltage of 12 volts, so you cannot charge it with a 12 volt charger. Now the black is the negative and red is the positive as always. So when I check the voltage, at present it is showing around 12.21 volts, okay, 12.21. So let's first connect the positive, okay. Now comes the negative, still 12.21, and you will see a sudden increase in the voltage, of course, because we are going to charge it right now. Okay, you can see the voltage has increased directly to 14.73 volts, as if there is nothing in the battery. And you can see the bubbles over here. You see the bubbles indicating the battery has started charging. But the point is that the voltage shouldn't have reached 14.73 so fast. Now we know the voltage, okay, so let's remove it and keep the charger connected over here. Yeah, this one like this. Now let's measure the current that this charger is feeding the battery, okay. At present, as you can see, that the current is around 3 amperes, so good amount of current is flowing. So all we have to do is wait until the battery gets a little warm and the charger also a little warm, indicating that large current has flowed from the charger to the battery. And it's safe to connect a 15 volts charger because this battery can reach a maximum of around 14.6 volts, and you have to leave it like this for around 12 or 14 hours. And yes, keep these knobs open while charging it, otherwise it produces gas which is going to push these up and these might just get lost. Well guys, it has been around 17 hours since the battery has been charging. Let's remove the terminals and see how much charge it has attained. Yeah, the charger is pretty hot.
So guys, keep watching the display screen. As you can see that the new voltage is around 14 volts. That is pretty good, 13.94 volts, which means that it is almost fully charged. Now let's connect the terminals and see how much drop it gains. You see it is not dropping to 8 volts. It is very hot, but it was maintaining the 13 volts. So our battery is obviously fully recovered. It's a 7 ampere hour battery. And I'm connecting a 5 amperes bulb. That is a pretty good load for this battery size. Once again, so guys, you see 13 volts, it's very hot. So this is how you are going to recharge and recover your battery that is fully discharged and easily attains 14 volts.